This video is going to cover the skill of solving multi-step problems that include using the formulas to solve for area and perimeter. When looking at a story problem that seems to have a lot of parts, it's important that we read through the problem first to just understand what it's saying, and then we can go back in and underline any important information. The rectangular playground at Ryder Park is 3 times as long and 2 times as wide as the rectangular playground at Maple Park. The playground at Maple Park is 8 feet long and has a perimeter of 28 feet. What is the perimeter of the playground at Ryder Park? Going back through, we're going to reread this and underline some important details. The rectangular playground at Ryder Park is 3 times as long and 2 times as wide as the rectangular playground at Maple Park. The playground at Maple Park is 8 feet long and has a perimeter of 28 feet. What is the perimeter of the playground at Ryder Park? A lot of information here, and I'm hoping it's clicking that this is going to be a multi-step problem. We've got to solve a couple of things before we can get to this final answer. So first off, I'm noticing that they're talking about 2 different parks, Ryder Park and Maple Park. So I'm going to go ahead and label those down below. I'm not getting a lot of information about Ryder Park. I'm going to draw out my rectangle and plug in what I know so far. Ryder Park is 3 times as long, so the length is going to be 3 times the length of Maple Park, and then the width is 2 times as wide as the Maple Park's width. So for now, I'm going to leave those empty because the next sentence looks like it's going to help us eventually get there. The playground at Maple Park is 8 feet long and has a perimeter of 28 feet. So I'm going to draw out my rectangle and plug in what I know. The length, it says, is 8 feet long. And then it doesn't tell me my width just yet, but it does tell me the perimeter. Using this information, I can find that missing side, which then will help me find the missing sides of Ryder Park. I know that my perimeter formula can help me find that missing length, so I'm going to plug in what I know. I actually already know the perimeter is 28. I know the length is 8 plus 8 plus x plus x, because those are unknown as of right now. I'm going to add up what I do know. So 8 plus 8 is 16. And now I just need to figure out 16 plus what equals 28. From here, I know that these 2 x's need to equal 12 because 16 plus 12 is 28. Splitting 12 in half, because my widths are the same, they have to be the same length, I'm going to get that each width is going to be 6 feet. Now that I know Maple Park's dimensions, I can now solve for Ryder Park's dimensions. Ryder Park's, remember, the length is 3 times Maple Park's length, which we know is 8 feet. So now I know that Ryder Park's length is 24 feet. And then I know that the width of the Ryder Park is going to be 2 times as wide as Maple Park's. And so this one is going to be 12 feet wide. Final question, though, is what is the perimeter of this Ryder Park playground? So using my perimeter formula again of length plus width plus width, I'm going to just plug in what I know. So the lengths would both be 24. The widths would both be 12. I'm going to do this part by part, getting me 48 plus 24. And then I can stack this below to get my final answer of 72 feet. Reminder, this is perimeter, so I'm not going to square this final answer. Definitely a multi-step problem. Drawing out models of each park was extremely helpful to solve this through, and also just going back to my story problem several times in order to get all of the information that I needed. Let's read through this next problem. The width of Ethan's rectangular swimming pool is 7 feet. The length is 4 feet longer than the width. Ethan has a rectangular float that measures 3 feet by 5 feet. If Ethan puts the float in the pool, how many square feet of space will be available for swimming? All right, so this one's going to be a little bit interesting because we're talking about a rectangular pool, and then the rectangular floaty that goes inside of the pool is going to go inside of that rectangular model. So let's go ahead and go underline some important details. The width of Ethan's swimming pool is 7 feet. The length is 4 feet longer than the width. His rectangular float measures 3 feet by 5 feet. And then if he puts that float in the pool, how many square feet, so we're talking about area here, will be available for swimming? So let's go ahead and start by drawing the larger rectangle, which is going to represent Ethan's pool because the floaty goes inside of the pool. Already tells us some information. It tells us the width is going to be 7 feet. And then the clue it gives us about the length is that the length is 4 feet longer. So if it's longer, that's going to be more than the width, so I'm going to add on. I'm going to add on to that width to get a length of 11 feet. Then I'm going to represent his floaty, and I'm just going to put it in the corner. Could be anywhere. And that's already, the information about this floaty has already been given to me. It's a 3 feet by 5 feet, so that means that either the width or length is 3 feet, and then the other is 5 feet. Now I need to understand what operation to do next. I want to figure out if that floaty is in the pool, how much more space is left over for swimming. So I'm going to take the area of the pool and subtract it by the area of the floaty to find out the area that's left over. So to solve for area, reminder the formula is length times width. So I need to find the area of the pool, but also the area of the floaty. So for the pool, I know my length is 11, my width is 7, so the area is 77 feet squared. While for the floaty, I'm going to have a length of 5 and a width of 3, getting me an area of 15 feet squared. Again, I'm trying to find out the leftover space to find out how much space is available for swimming. So I need to subtract the total minus the 15 feet squared to give me a final answer of 62 feet squared being left available for swimming. Again, going back to my story problem as much as possible to help me, one, label the parts I know, but also to help me understand what operation would make sense in order to solve for that final problem.